Hello students, this is the circuit for challenge number 9. If you check the description about challenge number 9, we need to control this a direct current motor, that is this yellow motor. I attach these motors into this plastic surface because I like to play with this, but it doesn't matter. You should have these motors all alone, and you don't need to attach them into the plastic surface right now. Okay? For this challenge, we are going to use the Arduino card that we already know. But also, as I told you before, if we want to control high current elements like a motor or maybe a computer or maybe a light bulb from your house, you need to provide a power interface. That is this card. Okay, you have this card on your kit. It's inside of a silver bag, and if you take it out it will look like this, and this card is a power interface used to control the direct current motors, and also it can be used to control the servo motors that we are going to use in for a challenge. But right now I want you to check this card and look into the letters wrote into the surface. I don't know, maybe it's not so clear here in the video because it's really hard to get focus, but if you check this, you will have M1, M2, and in here M3, and in here M4. I'm going to try to add a picture to explain this better. And here it is. As you can see, I have M1 connection. So this means that this and this is used to control the motor number 1. I got M2 connection, that is this and this. It's used to control motor number 2. And I got this M3 connection that is used to control motor number 3, and finally M4, that is motor number 4. So if you check the code, where is the code? Give me a second. Here is the code. I said that I am going to use the connection number 1. I'm going to use the motor number 1. So I need to connect my motor in these pins. Okay, we need to use this. Also, look at this. I have plus 5 volts in here, so that means that this hole and this and this and this and this and this, all these holes are connected to 5 volts. Okay, and I also have this ground or GND connection in this section. So all of these are going to be connected to the ground of my Arduino. So from this I can get my connection into my breadboard to ground, and from this into my breadboard to 5 volts. And finally I got this A0 to A5. So I got A0, F1, 2, 3, 4, and 5. Okay, so this is the layout from the card. So this card is used to receive the data from the Arduino, and then the control data sent by the Arduino is going to control this card, and this card is going to provide the power needed to control actually these motors. Okay, so this element is a power interface because the Arduino card has not enough power to run the motors. So the control signal provided by these elements goes into this card this card receives the data, and then this card provides the energy needed to move the motors. Okay, so in order to use this card with the Arduino, we need to attach this card into the Arduino. So if you see, these elements, these headers, fits perfectly into these elements, in those female headers. You see, we have male headers and we have female headers. So these elements attach perfectly in here. Look at this. See, it fits perfectly, and it has exactly the same shape in this corner and this corner, okay, and this corner with this corner, okay. It fits properly, so you should not commit a mistake connecting in another way, because there is no way. Actually, it looks really strange. Okay, so there is only one way to connect this with this. Okay, so when you fit it, you just press it, and that's it. Okay, now you have your power element attached into your Arduino card. Now we need to provide the control, actually the power connections to the motor. So if you check the program, you will see that I said that I'm going to use the motor number 1 connection. Now for this, because in my program I said that I want to use the motor 1 connection, I need to use the elements specified by M1. Okay, so I need to provide a connection in these two elements. So I need a screw remover. I move this, and if you see, when you turn this metal elements moves towards this direction. Okay, so now you can put the wires from the motor inside of this, and then if you move the screw in the other direction, it will attach properly. Okay, maybe not so properly, you need to do it stronger. Okay, that is it. It fits. You turn it down again, and that's it perfectly. Okay, and don't worry, actually direct current motors has no polarity. If you connect these wires in another manner, I mean if you put the black in here and the red in here, the only consequence is that the motor is going to turn in another direction. Actually, the way to change the direction of the movement of a motor for DC current motor is to change the electrical connection. You switch the connection. Okay, you connect positive in negative and negative in positive, and so it turns in one direction. And if you change the polarity, if you connect positive with positive and negative with negative, it will turn in another way. Okay, so now that I have my power connection, I need to provide the control connection. If you check the challenge, it says that you need one button to control the movement of a motor in one direction and another button to control the movement in another direction. So I need two buttons, and I need to send the data from the buttons to the Arduino card. The problem is that I have all this card above the Arduino card, so I cannot put any connection, but it doesn't matter. If you check the card, we have external connection elements. You see, here it says GND. That means that all these holes are connected to the ground connection of the Arduino, and we have +5 bolts, that means that I have 5 bolts in all these little holes, and these little holes are connected with the 5 volts from the Arduino card. Also, I have the analogic input called from A0 to A5 in here. So I have A0, A1, 2, 3, 4, and 5. Okay, so I can perform connections in here, and these connections goes to the Arduino card. Now, if you look these holes are like the holes from the liquid crystal display. So the best option is to you to attach headers in here and weld the headers in the same manner that we did with the liquid crystal display. Something like this, you see? These headers. But I know you don't have a welding iron at home, and you are not going to be able to weld headers in all these holes. So don't worry. We can do something really easy. We can use these male to male connectors, and then we only put them in here, and that's it. You have electrical connection. Of course, this is not the best way because it's really easy to remove, and so you can commit a mistake and this can move to another hole, or if you are not careful you can produce a short circuit or something and you can damage your card. So you need to be really careful and just put it in here, and that's it. And you need to be careful and prevent it to move like this, you see, because you are going to lose the connection and maybe you can have a problem, a malfunction. So first of all, I need to provide a positive voltage into my breadboard. So I want to provide a 5 volts connection into this red line, and with this wire I connect this red line with this another red line, and so I will have 5 volts in all these holes and all these holes, the red ones. Okay, so I look for the 5 volts holes and I place it in here. Okay, and now this guy goes to the red one. So the 5 volts from the Arduino goes to the 5 volts of the power interface card, and with this connection this 5 volts goes to all this red line. And with this wire I have 5 volts in all this red line. Now I want to provide also a ground connection, so I do exactly the same. I look for the GND pins, GND holes, and then I connect the male connector, and this goes to the blue one. So now I have ground in all these blue line holes, and with this wire I get ground in all this. Okay, so now I have my power supply into my breadboard. Now I need to provide the control signal, so I need to attach these buttons. As I told you, I rather to connect them in this way, because this way I have independent connection from this side to this side. You can do something like this. You can put them in the same side of the breadboard, and it's okay, it will work, but you only have 2 holes to work, and that's something I don't like it. It's only because I don't like it. I rather doing this, connecting in the middle of the breadboard, and this way I have more space to work. But it's up to you. As long as you respect the electrical connections, it doesn't matter where you place these buttons. Okay, so I am going to add 2 buttons, because with one button, the motor is going to move in this way, in this manner, and with another button the direction is going to change to another way. Okay, so I have two buttons. I need to provide the positive signal to my button, so I use these little wires to get the signal from the positive line, the red line, to my button. And then when I press the button, this positive is going to move from here to this little leg to the next leg, this leg. Okay, so let me provide the positive connection to my second button, and you need to be careful that you connect the positive with one leg of your button, because sometimes you commit some mistakes and you put the wire from this to this, and in here in the middle I don't have any electrical connection from the button. Okay, so maybe this is better. Yes, that is it. You see, from positive to the leg of my button, and again from positive to the leg of my button. If you place it like this, you have no connection, because here in the middle I don't have anything. I have a leg in here, I have a leg in here, and in the middle I don't have nothing but this wire. Okay, so be careful. I have seen a lot of mistakes like this, so be careful. Now, as I told you, we need to provide a ground signal to remove a noise, to remove a non acceptable voltage values. So we need to connect the second leg into ground using a resistance. In this case, any value of the resistance. So I put one leg of the resistance into the blue holes, and the other leg is connected into the other leg of the button. Actually, getting focus with this camera is a little bit difficult, but I guess you get the idea. So I do exactly the same with the second button, and now I have the positive signal that goes through the button when I press it, and I get the negative signal that goes into my card when I don't push the button. So now I need to provide the signal into my card. So the signal is going to be produced when I press the button. So the positive goes from the breadboard into the button. When I press the button, I close the circuit, goes through the button, and goes into this yellow wire. And if you check the program, my button, my signals are going to be connected into the A0 connection and A1 connection. So look at this. I get the description A0 in here. It's a little hard, but A0 to A5, and so this is A0, A1, A2, A3, A4, and A5. So this goes into A0. That's it. Okay? And the second button goes to A1. And that's it. That's all the circuit. It's really easy. Okay, so now I'm going to provide the electricity into my card. That's it, and nothing happens. But when I press one button, check the motor. Now it is turning, and it is turning in this direction, like this. and it will keep moving until I press the second button, and when I press the second button the turning direction change. Maybe you are going to be able to look at this. Now this is moving in this way. I press the other button and now it changed. Okay, and that's it. That's it for challenge number 9. I hope this is useful for you. I hope you are able to do this by yourself, and don't worry if you have any question and you need any help, try to contact to me and I am going to help you.